Hello, welcome back guys. This is Surendra and we are going to start magnitude representation. So the magnitude representation are classified into two category. First one is unsigned magnitude representation. Magnitude representation, and second one is signed magnitude representation. There is three part. Signed magnitude representation, second one is one's complement representation, and third one is two's complement representation. So for in unsigned magnitude representation, we can store only one positive number only. Here we can in signed magnitude representation we can store both type of number, positive as well as negative number. So we will study one by one. So firstly we will start with unsigned magnitude representation. So guys, in unsigned magnitude representation I have said that we can store only one positive number. So as we know that for n number of variable, we can have 2 to the power n possibility. This is we know that already. We know that. So for in unsigned magnitude representation, if we have like n bit, so we can represent 0 to 2 to the power n minus 1. Why I have taken minus 1? Because I am considering 0 also, so that's why I have here I have placed minus 1. In this possibility we start with 1, like, so that's why. So in unsigned magnitude representation the range is from 0 to 2 to the power n minus 1. So like if I take example of n is equal to 4 bit, so you can represent from 0, this is 0, 0, 0, 1, this is 1, till this is 15. So 2 to the power of 4 means 16 minus 1 is 15. So we can represent from 0 to 15. So then we will move to another topic, like signed magnitude representation. Like we have a second part is signed magnitude representation. So in which I have said that we can represent both the numbers. So we can represent both the numbers. What is both the numbers? So we can represent positive and negative. So in signed magnitude representation, the MSB bit is dedicated for sign. Like we have to represent both the, so means we have distinguished by some bit. So we have dedicated MSB bit for sign. If the like MSB bit is 0, then the number is positive number. If MSB bit is 1, then number is negative number. So here the if I take an example for 4 bit, so we can represent in two types, like this is for negative number, this is for positive number. So for 0, negative 0, this will be 1, 3 times 0. For minus 1, this will be 1, 0, 0, 1. For minus 2, this will be 1, 0, 1, 0. For, like that we can represent till minus 7. So minus 7 will be 1, 1, 1, 1. For positive, this will be 0, 0, 0, 0. This will be plus 0, plus 0. For 0, this is MSB bit. This is MSB bit. So for plus 1, this will be like that, and we can represent till plus 7. plus 7. So what will be the range? Like for 4 bit we have represented minus 7 to 7. So what will be like 2 to the power n minus 1 minus 1 for 4. 4 minus 1 3, 2 to the power 3 8, minus 1 7. So this is minus this 2, same as 2 to the power n minus 1 minus 1. So this will be the range for signed magnitude representation range. And there are two disadvantages. First one is that we have two representation for 0. So why this is a disadvantage? If we don't have two representation, so we can represent one more digit by same 4 bit, we can represent one more digit. So this is the disadvantage, first disadvantage, because we have plus 0 and minus 0. So these two are not different. So we have two representation for 0. This is disadvantage. So first is two representation for 0, and second one is that, like, if I want to increase the bit for same number, I want to increase the bit. So like I am taking for minus 7. So in 4 bit the minus 7 is like 1 1 1 1, as I have mentioned. In 6 bit, guess by what will be the minus 7. So 1 0 0 1 1 1. So if you want to increase the bit, then what you have to do? Firstly, you have to identify which is the signed bit, and then you will pour the zeros in between. So this is the disadvantage, because firstly we need to identify the signed bit, then after that we are pouring the 0. If we are able to make such system that we need not to identify signed bit, just do something that we can directly increase the bit, so that will be more convenient for us. So I am going to give an example. This problem will remove by 1's complement, in which we can if we will copy just signed bit, then we can represent we can increase the number of bit, like I will tell you later. But this is two disadvantage in signed bit representation. So we will go to the 1's complement representation. So friends, 1's complement representation. 1's complement, in 1's complement representation also, the MSB bit is dedicated for sign. If the MSB bit is 0, then this is a positive number, and if MSB bit is 1, then this will be negative number. So we need to concentrate here that if the number is negative, then for calculating magnitude we need to take 1's complement, then the decimal equivalent of that number will be the magnitude of that one, means by putting minus sign also. So I will give you the example. So firstly I will make table for time saving purpose. I am just pausing the video. So I have written this table. So like in for positive number, we the table is similar, so I will not like describe. But for negative, we need to concentrate on negative. So for minus 0, so just take the 1's complement of this one. So 1's complement of this one will be like, I have teach that subtracting by this is 3 bit. So write 3 times 1 and then subtract number. What that is, that will be 1's complement. But if you are complement, like for making 1 as 0 and 0 as 1, then it can calculate 1's complement. This is the method. So just complement it. So means this will be 3 times 0. So the magnitude is 0. So this will be minus 0. For minus 1, the MSB bit is 1, so B understand that we have to take 1's complement of this. So take the 1's complement of this one, so that will be 0 0 1. So the magnitude is 1, so the total magnitude will be -1 because the MSB bit were 1. So in this one the magnitude bit is 1, so take 1's complement, so this will be 0 1 0. This is the decimal equivalent of this is 2. So the total magnitude, because the MSB bit is 1, so total magnitude will be -2. So this is the case in 1's complement representation. So when if we will have to increase the number of bit, then we need to just copy the MSB bit into, like if you have to increase from 4 bit to 6 bit, so copy the MSB bit two more times, like two times copy the MSB bit only. Like for like I am taking the example of -7. For -7 the representation in 6 bit will be -7 in 6 bit. Like I have said that copy the bit 2 times more, so 1 1 1 3 times 0. We know the MSB bit signify the sign, so we know that this is minus, means minus some digit. So we have to calculate the magnitude of this digit. So just take the 1's complement of this one. The 1's complement of this will be 1 1 1 0 0 0. This is nothing but 7. So this will be -7. So just by copying the bit, we have done, like we have removed that problem, that first identify the bit and then pour the zeros. Here we need not to pour the zeros, just copy the bit how much times like you have to increase. So just copy the bit. I will cover 2's complement representation in next video. Thank you for watching the video, and please subscribe the channel, like the channel and share the video with friends, and thank you so much for watching.